this is a stoichiometry problem. The way that I know is that I'm talking about amounts of reactants and products. I'm supposed to find the amount of water that is formed in grams. Okay. The way that I know that this problem involves limiting reagents is that I have been given the amounts of two different reactants. And so I need to check and see if one of them runs out and therefore limits how much product I get. And I need to figure out which one that is. So when you see this situation, you have to consider each separately. Consider the calcium hydroxide, predict how much water it would make if it all reacted. Consider the hydrochloric acid, calculate how much water it would make, and then you'll compare the two predictions, and the one that predicts the lesser amount is your correct theoretical yield. So I'm just going to start with the calcium hydroxide and set up my normal stoichiometry steps. As usual, my first step is to convert to moles, and I do that using the molar mass of calcium hydroxide. I have been given that 74.1. Molar mass is always grams per mole, so the 74.1 goes down here with the grams and a 1 with the moles. Standard pattern of stoichiometry is to convert to moles. And once you go to moles, you can look at moles of this, go to moles of the substance you're interested in. And I'm interested in the product water. On this step, I get the numbers from the coefficients. And so I'm looking at the coefficient of calcium hydroxide is a 1, and the coefficient of water is a 2. It asks, I'm interested in getting to grams of water, so I'm going to go ahead. Right now I would be at moles of water. I'll do one more step. So those are my standard stoichiometry steps. I go from grams to moles, then I go from moles of one substance to moles of another using coefficients, then from moles to grams of my second substance. So that is my first theoretical yield, but we don't know that that's really right. We have to do this calculation for both. So we have to think about all the ingredients before we predict how much product we can get. So let's look at our other reactant. So we're going to do the same exact thing, starting with 50 grams of hydrochloric acid. So those are the same steps, just starting with hydrochloric acid instead. And I get a prediction here. Okay, so now I have two predicted amounts of water. What do I do? I choose the lower of the two. So I compare these two yields. And I'm going to choose the lower of the two. I'm going to cross this one out to make sure that I don't use it for anything because it's inaccurate. It's over predicting how much I would get. So here, this one is the theoretical yield. So when we were asked how much water would be formed, what we were asking for was the theoretical yield of water that could be formed. And this is my answer. It didn't ask this, but just to clarify this, if I wanted to know what the limiting reagent is, remember reagent means reactant. And so the limiting one is the reactant that predicted this lower number. So I'm going to go back here. This is the reactant that predicted the lower number. And it's not really the amount of it. The substance is HCl. And the excess reagent is the calcium hydroxide. The one that over-predicted the product. Now we're going to continue this problem with a part B. It is the same exact reaction, but I've rewritten it down here. Okay, so same reaction. I've already decided that my HCl is my limiting reagent, and my calcium hydroxide is present in excess. Okay, this is the amount that we put together, the amounts that we put together to react. This one all reacted because it's limiting, it ran out. So if I want to predict how much water, which we already did, was made, we start with the limiting reagent and we do stoichiometry. Okay, if we had started with the calcium hydroxide, it would have over-predicted our amount of water. Well, if we want to know how much of the excess reagent actually reacted, what I'm going to do is start with my limiting reagent and use stoichiometry to go to the excess. So in general, that's what I do. Once you know the limiting reagent, then if you want to find out any other amount, like if I wanted to find out how much calcium chloride was made, I would start with my limiting reagent amount, 50 grams, and do stoichiometry to get to it. But this time I'm going to see how much the calcium hydroxide actually reacted. So again, starting with my hydrochloric acid, usual stoichiometry steps, go from grams to moles. I like to sometimes just set up all the units kind of in order because I know the order, and then go in and fill in the numbers. So from grams to moles, that's where I use a molar mass. From moles to moles of different substances, that's where I use the coefficients. And this is the 2 and a 1 understood to be in front there. And then the relationship between grams and moles, again, is a molar mass, this time of calcium hydroxide. And now I have my amount that actually reacts. So I can start with my limiting reagent and do stoichiometry to find out how much my other reactant was needed to react. One last question. How much of the excess reagent was left unreacted? And so the excess reagent is the calcium hydroxide. how much of it is left unreacted? Well, at the beginning, we started with 55 grams. That was given. Before it reacted. And then we just calculated how much would react. And so we can subtract and get the amount that's left unreacted. Okay, and something that we can kind of watch for here is that, does that seem like a correct amount? Well, we would expect this number here to be lower than the original amount available. In other words, we had 55 grams of calcium hydroxide at the beginning. If this had come out over 55 grams, then we calculated our yield wrong, our theoretical yield wrong. So anyway, it did come out less, which makes sense. So we can subtract and get how much of our excess reagent is left over after the reaction has gone as much as it can.